This segment of Delmarva Life is brought to you by Chesapeake Eye Center.
Well, promising research on gene therapy could lead to answers to some of medicine's biggest mysteries, including AIDS.
Scientists have genetically engineered white blood cells to make them immune to the AIDS virus. Researchers say it seems safe and promising.
Our goal is to create an immune system that is resistant to HIV, that HIV cannot infect.
Well, HIV enters and infects an immune cell by binding to a molecule called CCR5. It's on the cell surface. 1% of all people lack this molecule and are naturally resistant to HIV because the virus is locked out of the cell. Dr. Tease and his colleagues extracted immune cells from trial patients and then disabled the gene for this molecule. The cells were re-injected into the patients to try to create resistance to HIV. As part of the study, 6 of the patients stopped taking their HIV medication temporarily. In 4 cases, the levels of HIV decreased. In one of those patients, the virus was reduced to an undetectable level.
And researchers are also reporting great success with an experimental gene therapy to treat advanced leukemia. Doctors take the immune cells of patients and modified those cells so that they could recognize and destroy cancer cells.
When we infused these cells into the patients became sick, as if they had a bad infection. But once the cancer cells go away, as they're being killed off by the immune system, that immune response goes away as well.
The result, 88% of the patients achieved complete remission. Researchers hope the experimental therapy may one day be able to treat other cancers, including breast and colon cancer.
Now, gene therapy is also offering promising results in preventing and reversing vision loss. In an Oxford University study, scientists injected a copy of a gene missing in patients who suffered from choroideremia, a rare genetic disorder that causes blindness.
Rather than taking a pill or proteins or taking tablets, we're actually correcting the disease at the genetic level.
Doctors say the results hold promise for age-related macular degeneration, the retinal disease that affects 1.8 million Americans.
Well, macular degeneration is the leading cause of vision loss in the U.S., so a treatment like this could help so many people.
So here to tell us more is Dr. Catherine Smoot, who is a board-certified ophthalmologist with Chesapeake Eye Center. Thank you so much.
Thank you for having
coming
me.
in with us this afternoon. So let me ask you this. Do you think that gene therapy could be considered a game changer in this field?
Well, no doubt about it. Now, how that game is going to change remains to be determined because we're very early on in the playing field. We haven't known about the human genome for all that long. You know what I mean? It's probably a decade or so, 10 years. A lot of supercomputer work, a lot of entrepreneurs trying to figure this out. We're starting to identify the genes associated with diseases. That's where it gets exciting.
So what is gene therapy?
Gene therapy, if you think about, we're made up with DNA and RNA. They're little fragments of that molecule that code for specific proteins. So proteins in our body make different parts of us work. Okay, we're sort of like a giant machine. If one of those proteins is missing, it's like having a loose wire in a computer or an appliance. It doesn't work right. You jiggle it, you fix it, you get it to work. So the question is, can we fix those missing proteins? Can we make that connection happen again?
So is the eye a good target for this?
The eye is a great target for it because it's tiny. We are able to deliver the gene therapy in a very small area, very small amount, so we don't have to worry about creating a reaction elsewhere in the body for the most part. We take very tiny amounts, but more importantly, we can see the results non-invasively. We can see the blood vessels through examination. We have tools that help us image the eye really effectively so we can gauge the results. So it is very exciting.
So macular degeneration is the result of a defective gene then?
Over 19 different genes have been identified and associated with macular degeneration, and more being found all the time. In 2010, the international science community got together and formed the Macular Degeneration Gene Consortium, and they keep adding these genes. So now we're thinking maybe all macular degeneration is not the same. So the promise is, can we A, either arrest certain forms, or B, can we customize the treatments for these individuals and hopefully prevent visual loss on down the road?
Okay, so not everybody gets macular degeneration. Is there some way we could know that we might be prone to?
Well, family history, certainly. Certain risk factors, lifestyle, such as smoking, put you in a higher risk group. But the only way you can be sure is with your eye exams with your eye care provider, a dilated retinal exam looking for that.
Okay, I'm going to ask you this question, and bear with me because I'm going to try to get this right. Could gene therapy actually prevent age-related macular degeneration from ever developing in the first place?
We'd love to think that. That would be the holy grail. Now, again, it's going to come down to years of research. I may not see that in my lifetime or you in your lifetime, but scientists are brilliant. The technology is amazing, and the hope is eternal. You know, the recent news has been Craig Ventnor and his Human Longevity Project, where they're going to map all these genomes and associate with your health records all the diseases, and these supercomputers, maybe they'll churn out, hey, this gene is this tumor, or this gene associated with the macular degeneration or diabetes, and we'll start targeting treatments. And you know, it could be a really exciting time. I think we're at the tip of an iceberg in terms of gene therapy, and our results are early. The eye study you talked about was only 6 patients. It's early. We don't know dosing. There's a lot we don't know, but the fact we see any response is like enough to keep moving, that motivation.
Now, in the Oxford study, they said that the scientists were replacing a gene. How did they develop, how did they create the gene that they replace it with?
So is what they do, they identify the segment of DNA that is abnormal or not coding for the right gene or that they want to replicate or block. Then they create a wild gene. They synthesize that in the lab. They hook it to a delivery system, which in the case of the eye is an adenovirus.
Right.
The same thing that gives you pink eye,
Yeah.
a really aggressive little guy. They hook that gene to that adenovirus, and then they actually inject it in the eye under the retina. And the little adenovirus then kind of infects the tissues and dumps that wild RNA into the normal cells, and then we hope that it functions and starts coding the proteins that we'd like. And that's the theory behind it.
Dr. Catherine Smoot, thank you
It's
so
always
much.
a pleasure.
Wow,
Thank you.
great
Thank
stuff
you.
there, huh?
And if you missed any of this information or would like to read more about Dr. Catherine Smoot and her staff at Chesapeake Eye Center, go to our website, delmarvalife.com, and click on the Show tab.
So, as we just learned, macular degeneration can lead to vision loss, but there are so many other ways that it can happen. Tomorrow, how a training facility here on Delmarva is helping seniors who've lost their vision regain their independence, and how you or someone you know can take advantage of the program. So, if you're a parent, you know our kids just grow up too fast.
But now there's concern over just how fast our little girls are becoming women. Still ahead on Delmarva Life, it's an awkward time to begin with, and some girls are hitting it before their 10th birthday. What doctors are blaming for the earlier onset of puberty, plus why exposure to chemicals and items we use every day could be partly to blame.
And later on, 1 in 5 adults in the U.S. report some degree of hearing loss. That loss can start happening as a child. So how do you know if you or your child are losing this important sense? We're going to sit down with a hearing expert. But first, back to our eyes. Dr. Smoot told us about macular degeneration. Dr. Oz has more on what we can add to our diet to help keep things in focus.
The eyes are the windows to the soul. So here are some things you need to know about warding off eye disease. It's called macular degeneration, and it's a leading cause of blindness in Americans, and it steals your central vision. At first, you may find it harder to read, drive, or recognize the kids selling cookies at your front door. But it can slowly progress to the point of no return if you don't protect yourself. So what can you do to keep things in focus? Well, a lot actually. Antioxidant vitamins A, C, and E help. You can consume a diet high in the plant pigment called lutein and with omega-3 fats. And avoid refined carbohydrates that cause a rapid increase in blood sugar. And always remember to protect your eyes from the sun.